What if I told you the sound of train passing by holds the key to understanding one of the greatest mysteries in the universe? Listen carefully. This simple observation isn't just about sound. It's the same phenomenon that provides evidence that our universe is expanding every single moment. But how does it all connect? Stick around because this question will take us from train tracks to the edge of cosmos. In 1842, Australian physicist Christian Doppler proposed a theory in which he suggested that the frequency of a wave changes depending on whether the source of the wave is moving toward or away from the observer. It might sound technical, but it's actually quite simple. Let's break it down using a train as an example. Picture this: you are standing still at a train platform, and there's a train coming toward you. As the train gets closer, you can hear the sound of its horn. But here's the important part: the sound seems to get higher in pitch the closer the train gets. Why? It's because as the train moves toward you, it pushes the sound waves closer together. This makes the wave more frequent, and when waves are packed closer together, the sound becomes higher. Now, after the train passes you and moves away, the sound gets lower. Why? This happens because the train is moving away from you, and as it does, it stretches the sound waves apart. This causes the waves to become less frequent, and when waves are spread further apart, the sound becomes lower. So, the reason why you hear the sound changes is because of the way the train's motion affects the sound waves. This is the Doppler effect. Waves changing their frequency depending on whether the source is moving toward you or away from you. Doppler predicted that this same effect could also apply at light waves, even though no one had yet observed such a phenomenon. His theory was groundbreaking, but at the time it was met with skepticism. Scientists believed that light traveled through a substance called ether, a mysterious, invisible medium that they thought filled all of space. They couldn't imagine how the motion of object in space could affect light waves. As a result, Doppler's prediction remained speculative for many years. Despite this, the idea that light could be affected by motion remained on people's mind, and it wasn't until the early 20th century that the first breakthrough came. In the 1920s, astronomers began observing galaxies that were moving away from Earth. To their amazement, the light from these galaxies was shifted toward the red end of the spectrum, a phenomenon known as redshift. This meant that the wavelengths of a light were stretched out, much like the sound waves of the train. The discovery was a confirmation of Doppler's theory. But there was still a catch. Scientists initially struggled to accept that light, like sound, could be influenced by motion. It wasn't until the work of Edwin Hubble, whose observation of distant galaxies in 1920s revealed that galaxies were indeed moving away from us, that the concept of an expanding universe was confirmed. The Doppler effect, once a simple theory about sound, was now seen as the key to understanding the vast, ever expanding cosmos. Imagine the thrill of being the one to unlock such monumental truth about our universe. If Doppler's effect amazes you, or if you have any thoughts on your mind, let me know in a comment section. And check out more amazing and mind blowing videos on cosmic colors. And don't forget to subscribe for more.